Greetings and welcome to week 1 of Scientific Research Methodology MOOC. In this section of M1.4, we will have a look at the elements of research methodology. With the background knowledge about the type of research, what the research process entails, and how that process should be carried out ethically, let us now focus on the elements of research methodology which need to be considered while planning a research study. These elements must be addressed while writing an outline of a research project for academic purpose and for writing a research proposal for a research grant. These are research problem, hypothesis, variables, experimental design, and data documentation and analysis. In this section of part 1, we will be focusing on research problem, hypothesis, and variables. Let us consider the next element of research methodology, variables. The literal meaning of the word variable is something that is not consistent, which can therefore undergo changes. Variables in a scientific study, therefore, are those parameters which can be changed or adjusted in order to lead a scientific inquiry based on the hypothesis framed. Let us go back to the example we had discussed about the pharmacokinetic research. The study there had prediction about favorable outcome of the drug effect. Here, we understand that the concentration of the drug would definitely matter for the inhibition of the bacterial growth. Therefore, the researcher will have to consider this as a variable and try out different concentrations to get the best result in order to prove the hypothesis. Thus, variables play an important role not just in testing of the hypothesis but also in constructing the appropriate research plan whereby their interactions or relations can be studied. Thus, we can define variable in the context of scientific research methodology as a characteristic that can take different values, at least two. There are two categories of variables based on the measurements related to testing the hypothesis that can be made using these: quantitative variables and qualitative variables. Quantitative variables are the characteristics or parameters which can be actually measured. For example, the readings of power, voltage, or current, etc., delivered by a circuit, the concentration, pH, normality, etc., of a solution, number of bacterial colonies on a culture plate, etc. It is possible to manipulate such variables so that the outcome can produce the favorable results as expected. All such measurable and quantifiable variables are categorized as quantitative, and mostly the empirical research is based on these. Qualitative variables are the characteristics or parameters which cannot be actually measured, as they describe the abstract qualities or attributes or discrete categories. For example, the behavioral studies seen due to the effect of a psychotropic drug. Here, the observations made would be categorized such as the type of movement, maybe slow, medium, fast, etc. Another example could be of the research study based on epidemiology of a disease, based on ethnic groups, gender, etc. In order to have the further analysis of data obtained pertaining to the qualitative variables, often scoring system is applied so that quantification can be made. For example, attributes like slow, medium, fast could be categorized as per the speed or time taken to cover a particular distance. The subjects belonging to different groups in the epidemiology study can be counted. Usually, the descriptive type of research studies are based on such variables. Considering once again the example of pharmacokinetic research study, we can consider two variables. One is the concentration of the drug and the second is the respective inhibition observed in the bacterial growth. As both of these are measurable, these are quantitative variables. I would like you to please consider these two questions. Question 1. Would the varying concentration of the drug affect the rate of inhibition of growth? And question 2. Would the inhibition of the growth affect the concentration of the drug? I would request you to please pause the video and quickly write down your answers. Thank you. Many of you may have given the answer to question 1 as yes and answer to question 2 as no. This is correct because the rate of inhibition can be manipulated by the varying concentration of the drug, but the concentration of the drug cannot be manipulated by the inhibition rate. Thus, hypothesis testing is based on the outcome of the data gathered with respect to the variables chosen and their relationships with each other. So, here we have a situation of a cause that leads to a corresponding effect. The variable of concentration of the drug is the cause and the resultant rate of inhibition is the effect. The two such variables are termed as independent, which is regarded as cause, and the dependent, which is regarded as the effect variables. Such two variables can have different types of relationships between them, like if one variable increases in its magnitude, correspondingly the magnitude of the second variable also increases. As we say, they are directly proportional. This relationship is called positive relationship. Increases in the magnitude of one variable, if leads to a corresponding decrease in the magnitude of the second variable, as we say they are inversely proportional, this would be called negative relationship. Such relationships between the variables are considered while framing the hypothesis. Accordingly, the hypothesis can be expressed in terms of null hypothesis and alternative hypothesis. The data gathered will then help the researcher to either accept the hypothesis or reject it. Null hypothesis is when the researcher assumes that there is no relationship between the two variables chosen. You may now also understand that in such a case, the two variables considered would be of independent type. Alternative hypothesis would be an assumption different from the null hypothesis, where the researcher hypothesizes that there could be a positive or negative relationship between these two variables. Thus, the research plan would be based on these guidelines. The testing of hypothesis may either lead to an outcome of either accepting the null hypothesis or rejecting it. If null hypothesis is rejected, then the alternative hypothesis is accepted. I would now like to end this submodule with the quote of the famous Nobel laureate physicist Enrico Fermi, who mentioned that there are two possible outcomes. If the result confirms the hypothesis, then you have made a measurement. If the result is contrary to the hypothesis, then you have made a discovery. Thank you for completing this section of M1.4 of week 1.